Recording in progress. Recording stopped. Recording in progress. Recording stopped. Recording in progress.
Okay, please let me know. Can you share the shared presentation? Can you see it?
Yes, sir, we can see.
Okay. So from the last week that you can remember that we discussed about the sensors, and in that part we discussed about the sensors that we use to liquid measurements. And after that, we discussed about this about the light sensors under that category. Phototransistors and photoresistors. So by using these light sensors, that we can make another position and proximity sensor type. So today we are going to discuss about those sensors. So those are named as photoelectric sensors. So actually these photoelectric sensors that we have to consider them under the category of motion, position and proximity. Okay. So normally in a photoelectric sensor, there is a emitter and a receiver. So think one side is emitter, another one side is a receiver. So one emit a light beam and the other side receives it. That receiver in, there is a light sensor. So it can be a photodiode, a phototransistor, uh, or photoresistor. So no matter that, we use that component to receive that light beam and detect whether the emitted light is coming toward the receiver. Okay. So this principle is used in the photoelectric sensors, and normally we use a light source for these photoelectric sensors, and it can be infrared or visible light. So that visible light is mainly that we use the green color, the red color and the green color, and as well as in some cases we use the blue color also. So let's move on. What are the types of these photoelectric sensors? But before that, we want to learn about what are the advantages of photoelectric sensors. So normally, the photoelectric sensors have the non-contact sensing capability. So this is very important. You can see it in the fifth fact as the fifth fact. But this is very important because normally only using a light beam that we can detect an object without any contact. Okay. Then the other thing is, now you know that the light beams can travel long distance. Therefore, normally the photoelectric sensors have long sensing distance. So actually you should know that these are very simple to understand and remember. Just think about a light beam. The quality of the light beam is, we can see inside these photoelectric sensors. කෙලින්ම photoelectric sensors වල තියෙන්නේ දැන් අපි පාවිච්චි කරන light beam එකනේ. ඒතකොට ඉතින් light beam එකේ තියෙන ගතිගුණ ටික ඉතින් මේ photoelectric ඒවල තියෙන වාසි ටික මේ photoelectric sensors වල තියෙනවා. So the first one, light can travel long distance. So therefore, the photoelectric sensors have long sensing distance. And the next one is virtually no sensing object restrictions. So that's mean normally a light beam can restrict by any object. So therefore, we can use these photoelectric sensors to detect any type of object, regardless its material, color, shape, or the surface. So regardless those things that we can detect it by photoelectric sensors. That means virtually there is no any sensing object restrictions. And the next one is fast response time. So you know that light beam can travel fast. So therefore, it has a fast response time. That means if there is any small change, any change in the object, so suddenly it is detected by the receiver, and that means by the photoelectric sensor. Okay. The next one is high resolution. So you know one light beam is made of uh, millions of light rays. So therefore, it can be used to there we can use it for with high resolution. So that's mean by that these photoelectric sensors can use to detect very small object or very slight changes in position very accurately using these photoelectric sensors. And non-contact sensing I mentioned you. And also the photoelectric sensors can be used for color identification. Now you know that some surface can absorb the color and some surface uh, some surface reflect the colors totally. So therefore, using that principle, that we can use the photoelectric sensors for color identification also. And the next one is easy adjustment. So there is only emitter and the receiver. So there's two component. Using those two, we can easily adjust the photoelectric sensors. So these are the advantages that we can see in photoelectric sensors. Now let's move on to the part that what are the types of these photoelectric sensors. Okay. Uh, the first one. So first one is a through beam sensor. So in that case that you can see, here is the emitter which emits the light beam, and here's the receiver. And if you can see, if there is no any object, that light can travel from the emitter to the receiver. So wait, I will draw this. Can you see what I'm drawing?
Yes, sir.
So you can see if there is no any light, object. So here is the emitter and here is the receiver. So this light can travel without any restriction. So therefore that you can see this object will be the restriction from this light for this light beam. So therefore, that's mean if there is any object present through in the middle of this emitter and the receiver, that the light beam cannot travel to the receiver. So in that case, the receiver detect that the present of the object. So this is called a true beam sensor. So you can remember this, how one you can detect the object when one when object travels through the beam. So this is the light beam. If it is travels through the beam, so it is called a true beam sensor. So normally in a true beam sensor, the emitter and the receiver will emitter and receiver placed in the two sides of this object. So therefore, you can easily understand it. Did you get this? Make a පැහැදිලිද?
Yes, sir.
Okay. So let's move to the next one. So this is called the retro reflective sensor. So before that one, tell me what is a retro reflector? So I know all of you have seen this material, but let me know what is retro reflective material. Retro reflector material එකක් කියන්නේ මොකක්ද? ඔයාලා දැකලා තියෙන එක sure. I know that you all got this PDF last week, so therefore that you could read this. What is a retroreflective material? Okay, tell me, have you seen the road signs when you are traveling? පාරයක්දී මාර්ග සලකුණු එහෙම දැකලා තියෙනව නේද? දැන් අර ළඟදී අපි මේ කැම්පස් එකේ පිට්ටනිය ගාව එහෙම පාරේ හයි කරේ ස්පීඩ් ලිමිට්ස් එහෙම. So you can see the retro reflector material inside there. So how you can recognize that those are the retro reflector materials? Because when you aim a light at that material or at that board, it reflect the light beam towards the source. So normally we know if it is not a reflective surface, the lights will scatter. But if we use a retro reflective material, so that material reflect the light beam towards its source. You know, light is emitting from a source. That material reflect it towards the source. So in that case that you can understand, if there is no any object, before that I will explain you the configuration of the retro reflective sensor. So therefore in this sensor, the emitter and the receiver in same housing. So you can see in the last one, between the true beam sensor, that the emitter and receiver is in separate houses. But here you can see the emitter and the receiver in same housing. So therefore, when there is no any object, what's happened? If there is no any object, the emitted light beam can traverse to this retro-reflective material. Then what's happened? It reflects toward its source in the direction towards its source. So therefore, normally the light beams goes and travels to the receiver. So that's mean when there is no any object, no present of any object, this receiver receive the light. But if there is an object present in the middle of this beam, that's mean the surface of the object is normally not a retro-reflective material. So therefore, this light beam absorbed by this surface. So in that case, when there is a present of any object, the receiver did not receive sufficient light. That means the amount of the light it received will be reduced. So therefore, by this reduction of the light intensity, that we can detect an object by using the retro-reflective material. සිංහලෙන් එක්ස්ප්ලේන් කරන්න කියලා තියෙනවා. හරි. දැන් true beam එක නම් කියලා තේරුම් ගන්න පුළුවන් නේ. retro reflective කියන්නේ මැටීරියල් එකක් තියෙනවා. එයාගෙන් කෙරෙන්නේ මොනවාරි ලයිට් බීම් එකක් එනවනම් ඒ ලයිට් බීම් එක ආපහු ඒ එන මූලාශ්‍රයටම source එකටම. So you have to use this terminology. මේ වචන හරියට මතක තියාගන්න. මේ වචන ටික ඕන. එතකොට source එකට ආපහු reflect කරනවා නම් අපි යාට කියනවා retro reflective material එකක් කියලා. So normally මේ material එකක් කරනවා material එකක් තියෙද්දි අපි light beam එකක් ගියොත් එහෙම මේ light beam එක ඒ receiver emitter එක පැත්තටම යනවා. ඒතකොට emitter එක පැත්තටම යනවා කියන්නේ එයා receiver එකට එනවා. හරි. ඒතකොට අනිවාර්යෙන් ඔයාලා exam එකේදී අහුවොත් retro reflective material එකක් කියන්නේ එයා receiver එකට එනවා කියලා හරියන්නේ නැහැ. මොකද receiver එක කොයි තියෙන ඕන තැන තියෙන්න පුළුවන් නේ. ඒතකොට retro reflective material එකක් කියන්නේ අනිවාර්යෙන් එන්න ඕන එයාගේ light source එකට. හරි. එතකොට ඉතින් normal අවස්ථාවේදී මෙයා light එක reflect වෙලා receiver එකට එනවා. හැබැයි object එකක් මැද තියෙද්දි retro reflector එක වෙතට light beam එක යන්න බැරි හින්දා ආපහු මෙයා receiver එක පැත්තට එන්නේ නැහැ. එතකොට මොකද වෙන්නේ මේ object එකෙන් මේ light beam පුරා ගන්න හින්දා මේ receiver එකට හම් වෙන light එක amount of light එක අඩු වෙනවා. එතකොට ඉතින් අනිවාර්යෙන් මේ sensor එක detect කරගන්නවා. මොකද්ද මෙතන object එකක් present වෙලා තියෙනවා කියලා. So like that, this is how we can use the retro reflective materials to detect objects. Okay. So the next one, diffuse reflective sensor. Let's tell me what is diffusion. That you have learned it in A levels. So that is why I am asking this. What is diffusion? බාන්ස් එකක් දෙන්න. විසරණය කියලා එකක් අහලා නැද්ද? You have to keep the interaction ඈ. මම දැන් ඇහෙනවද නැද්ද කියලා දන්නෙත් නැහැ. So if you can't speak, you can coming through the chat box also. So okay, no one. It seems that no one can remember that diffusion. So diffusion means the scatter. Scatter means like විසිරලා යනවා වගේ. So the diffusion means scatter. Or we can say spreading of the light beam in many directions. So when it is a strike object or whether it is passing through any medium that we can see the light beam will spread. So this is called the diffusion. So normally in the diffuse reflective sensor, so it's used the diffusion to detect and the presence of an object. So see how. So if there is no any object, what's happened? This light beam can traverse towards the infinity. So that's mean in this case you can see the emitter and the receiver is in the same housing. So therefore, when there is no any object, the receiver do not receive any light. But what's happen if there is a present of any object? So it's like this. So you can see this emitted light strikes the sensing objects. Then it's reflect the lights towards this receiver. So in that case, what's happened? The intensity of the light which is received by the receiver will increase. So therefore, in that case, that you can understand when the light, the amount of the light received by the receiver is increasing means that there is a present of an object. So now you can compare and contrast them with the previous photoelectric sensors. So you can see in the true beam sensor and in the retroreflective sensor, the receiver and the emitter, when the receiver do not receive sufficient amount of light when there is a presence of an object. Object එකක් තියෙනලාවට මේ දෙකේදීම receiver එකෙන් light receiver එකට එන light ප්‍රමාණය අඩු වෙනවා. හැබැයි but when we are using a diffuse reflective sensor, that means if there is a presence of any object, the amount of the reflected light will increase. මේ වෙලාවෙත් receiver object එකක් ආවට පස්සේ receiver එකට එන light ප්‍රමාණය වැඩි වෙනවා. So this is the principle that the principle of the diffusion is used in diffuse reflective sensor. Okay. So let's move on to the next sensor. So it is a distance settable sensor. So normally in the three sensors that we discuss, through beam, retroreflective, and the diffuse reflective. So in all the three cases that we only could detect the presence or absence of any object. That means the proximity. But by using the distance settable sensor, that we can detect the position of the sensor. So position of the object. So here there is a emitter that it emits the light beam, and in here we use normally receptors, not a single receiver. So therefore what's happened? So according to the sensing range, that means between the sensing range, according to the position of the object, the receptor receives the light reflected from the object in various angles. So you can see when the object is here, right? When the object is at the position 1, this angle is, we can consider is alpha. So if the object is at the position 2, so the reflected angle will be, we can consider it as, take it as beta. Then what can you say about the relationship between alpha and beta? Is it alpha is greater than beta or alpha is less than beta? So what can you say? So you can just see the image and tell me. What can you tell about alpha and gamma? So which is the greatest angle? So please, you should give me the answers. Which one is correct? Is the first one or second one? I will wait until you answer come. Yes. So this the first one is correct. So that's mean we can consider the angle of the receiving light. So according to that angle, the concentration of the light beam on the receptor will change its position. So therefore, according to that, we can set some distances according to those angles. So therefore, in that case, according to the angle that the light beam received by the receptor, we can say what is the position of the object. Got it? So this is called the principle of triangulation. මේ object එක තැනින් තැනට වෙනස් වෙද්දී එයාගෙන් රිෆ්ලෙක්ට් කරලා යවන කෝණය වෙනස් වෙන හින්දා මෙන්න මේ රිසිප්ටර් එකේදී මේ ලයිට් බීම් එක කන්සන්ට්‍රේට් වෙන තැන වෙනස් වෙනවා. සහ යාට එන ඇන්ගල් එක වෙනස් වෙනවා. එතකොට ඒ ඇන්ගල් එක අපි කලින් මාක් කරලා තියාගත්තොත්, so by using that angle that we can say what is the position of that object. ඔබ්ජෙක්ට් ඇන්ගල් එක එනවා. ඒ ඇන්ගල් එක අනුව අපිට කියන්න පුළුවන් මේ වෙලාවේදී ඔබ්ජෙක්ට් එක තියෙන්නේ මොන පොසිෂන් එකේද කියලා. හරි. So this is the distance settable sensor. So let's move to the next one. So this is the final one. This is called the limited reflective sensor. So by this one, we can only only detect the objects when they are in a specific distance, not like the previous sensors. So let's see in a through beam sensor, in a retroreflective sensor, or in the diffuse reflective sensor. What's happened? Whether the object is placed here or here or here, that means in any place in between the emitter or the receiver, that it only detect as a presence of that object. And in this one, retroreflective sensor, or in the diffuse reflective sensor, what's happened? In all the cases, regardless the position of the object, that a receiver detects the change in the light intensity. But in the limited reflective sensor, so it's not like that. So it's only detect the object when it is placed in a specific distance. So you can see here, this is the preset side, and here this is the emitter, and here is the receiver. So when the object is in the predefined range or predefined position, so what's happened? When the light emits, it strikes the object, then this object is scattered or reflect the light beam. So therefore it is received by this element. But think, if this object is in any other place, so here think this is the predefined place, but this is not a defined place. So what's happened? If the object is present here, when the emitted light strikes this object, it scatters and as well as it reflect in light in this angle. So according to the reflection rules, it strikes and making a same angle, and if it reflects. So therefore, what's happened? This light beam, that means where though the emitted light hits this object and reflected, but this receiver does not receive that light. So therefore, that's mean by this limited reflective sensors that we can detect the objects which is in which is at a specific distance. So I think you got this. So okay, these are the 5 type of photoelectric sensors. So you should have a clear understanding about these photoelectric sensors. So those are true beam sensor, retroreflective sensor, diffuse reflective sensor, distance settable sensors, and the limited reflective sensor. Uh, so please let me know if there is any confusion within these things. Otherwise, if not, that we can move forward. And also that means that why I'm saying that you should have a clear understanding, because that you have to compare and contrast this compare the type of the various type of these photoelectric sensors. Okay. So the next type is the laser sensors. Actually, these laser sensors are also similar to these photoelectric sensors. So here in every photoelectric sensor that you can see, emitted light beam is used. So when we are using the laser sensor, so the only thing is that the emitted light is not a normal light, it is a laser light. Okay. Now tell me that as you know about the laser lights, so what are the advantages, or tell me what are the qualities of a laser beam other than a normal light beam? Normal light beam එකකට වඩා laser beam එක තියෙන වාසි හරි මොනවද වාසි? මේ qualities මොනවද කියන්නේ? Oh, that you should give an answer. දැන් laser beam එක මොනවද තියෙන qualities කියලා කියන්න මතක නැද්ද? Okay, until you give an answer, I will wait. පරිවාල උත්තර දෙනකම් මයින්නකෝ. නැත්නම් දැන් මොකුත්ම අහන් ඉන්නේ නැහැ. Yes, I got one answer that laser beam travels in a straight direction. So actually, I appreciate that you have given at least an answer. That's okay. Here's that we can say light beam travels in a straight direction, and that means every light beam travels in a straight direction. But normally, that in where there are lasers, so normally that we use the light beam with a with one phase, same phase. So that's mean that normally by using a laser beam that we can have narrow, highly focused or more intense beam of light. So therefore, we can have very high accurate measurement in positioning or detection because it does not scatter. අනිත් වගේ විසිරලා යන්නේ නැහැ. Not diffuse. So we can use these laser sensors instead of the photoelectric sensors. That means actually I told you when you are remove the emitter, that means when you are replace the emitter of the photoelectric sensor with the laser sensor, so laser, that you got a laser sensor. So therefore, these laser sensors are normally used as laser distance sensors, laser displacement sensors, laser photoelectric sensors, and positioning lasers. So laser edge detection sensors. So every sensor that used with laser is called a laser sensor. Okay, now you know what are the laser sensors and you know how you can develop a laser sensor using a photoelectric sensor. Okay. So the next one is the fiber optic sensors. So this also, now you know that I got a answer that normally the light beam travels in a straight direction. Yes. But using the fiber optics, what we can do that we can bend the light beam. So using the qualities of the light and the fiber optics are high dense material. So therefore, that the light beams travels only through this fiber optics. So therefore, we can change the direction of the lights and travels the light from the emitter to the receiver without having an straight direction. So using the principles of light reflection and the refraction, mainly by in the fiber optics, the refraction is used and the attenuation. So these fiber optic sensors works. So in that case, that how let's identify how the fiber optic sensors works. So normally you can see in this type of a photoelectric sensor, this light beam travels in air. There is no any medium to the light to travel. But by the fiber optic sensors, this traveling medium is made with fiber optics. So therefore, this fiber optics travels in various places. So when it travels in various places with various cross-sectional areas of the fiber optics. So according to those, there can be change in the receiving light. At the receiving end, the light will somewhat differ from the light emitted at the emitting end. So therefore, this principle is used by the fiber optic sensors to measure. So there are many types of fiber optic sensors. So normally the fiber optic sensors can be used in a wide range. So the pressure sensors are made with fiber optics, gyroscope sensors, chemical sensors, almost all sensors can be made using this fiber optics. So because why the fiber optic sensors are very important? So because normally these offer an advantage such as the immunity to the electromagnetic interference. So the fiber normally the light beam can be interfered by electromagnetic waves. So by using the fiber optic sensors, the fiber optics isolate the light beam from the outside environment. So therefore, the electromagnetic waves from the outside environment do not affect the fiber optic, the light beam inside the fiber optics. And also by using the fiber optics, as I told, the light beam is isolated from the outside environment. So therefore, there is no any wastage of the light. So then you can have a high sensitivity. And also, as the isolation, it has the ability to operate in harsh environment. So that means the changes in the outside environment does not affect the light beam which travels inside the fiber optics. Okay, these are the types of the sensors that we are discussed from the beginning. That we have discussed about many types of sensors, but today I think that you have a good idea about photoelectric sensors and what are the laser sensors and what are the fiber optic sensors. So you can see the laser sensors are and the fiber optic sensors are also using the working principle of the photoelectric sensor. So therefore, it's only change. That means the laser sensor only replace the emitting part, and the fiber optic sensor is only replace the traveling medium of the light beam of the photoelectric sensor. So these are the sensor types that we want to know in our syllabus. Okay. So we can conclude the sensor part, but we want to move to the next part, it is actuators. Okay, wait. Okay, please let me know that can you see this presentation as well? මේ පේනද? Can you hear me? මම අහනවද? Ah, so okay, that got the answer that you can see it. So okay, in the next part that we are going to discuss about the actuators. So these are also very important components in the control systems and in digital control operations that we can see the actuators. Uh, so normally we should want to know what is a digital control. So normally, you know, in the modern systems, uh, a digital computer or a microcontroller is act as a controller. So that means this controller generates the digital control signals based on the sensor feedback and programmed logic. So, however, these computers uh, cannot directly move motors or valves. So, therefore, we need an intermediate device. It is called the actuators. Actually, there are some another intermediate devices like signal condition units, ADCs, that mean analog to digital computers, and DACs, digital to analog converters as well. But it's also an intermediate device, and also the driver circuits also can be considered as the intermediate device. So actually, what you should know, normally a microcontroller sends a low power signal. But the actuator, so that means to perform the action we need, should have an amplified signal. So that means there should be an amplifier, and then after that, an actuator received the given signal by the controller and it perform its physical action. Okay, now you know what is mean by the digital control. So then we should know our main part and what is an actuator. So let's understand what is an actuator. So you can see an actuator is a device that received control signals or energy and convert them into physical movement or mechanical force. That I use the red color for the fonts. So therefore you can see those are the keywords. So an actuator receives control signals or energy and convert them into physical movement or mechanical force. So normally, in simple words, that we can say that actuator converts the electrical commands into real world physical actions. So normally, these physical movements or mechanical force, that means the output actions of the actuators can be a rotational movement or a linear movement or a positioning or opening or closing valve. So like that, those are the physical movements. And by those movements that using those actuators that you can move, lift or rotate or push or pull or those are the physical movement that you can do using an actuator. Okay. Then let's see. Let's go on to the classification of the actuators. So actually before that, I will tell what's happened here in this block diagram. So you know this in this part that we discuss about the controllers. So it's the controllers generates the control signal and it's applied. The signal is applied to the actuator and then the actuator produces this physical movement. Okay, now let's move on to the classification of those actuators. So normally we can classify the actuators using the type of energy utilized. So the first one is electrical actuators. So normally in those cases that we can get the transistors, MOSFETs, it means metal oxide semiconductor field effect transistors. Those are the MOSFETs, and the thyristors as electrical actuators. And they are called the actuators electromechanical actuators. So DC or AC motors, stepper motors, and the servos can be classified under that type of actuator. And the electromagnetic and the solenoids can be classified under electromagnetic actuators. And which are the actuators do not use the electric signal? That means the control signal is transmitting used hydraulic or pneumatic. So those type of actuators are called pneumatic and hydraulic actuators. So there are valves pneumatic valves, hydraulic valves, pneumatic cylinders, hydraulic cylinders, and air motors. Those are the type of the actuators. Those are the example for the actuators under this pneumatic and hydraulic actuators. Okay. So the first one is electrical actuator. So normally electrical actuator is mainly used for this on-off control. And they consumes a very low energy. So therefore, normally these are used for as it's consume low energy and also it's giving the on-off type signal. We can use it for the switching device. Got it? And normally that MOSFET is a good example for this electrical actuator. So here you can see a MOSFET and here also. And like the transistor that you can see three legs, emitter, base, and the collector. So like that, there are three legs of the MOSFET. It is a great gate. That means it is like the base of a transistor, and source is like the emitter, collector, and the drain is like the emitter. So normally in a MOSFET, the gate terminal receives the low power signal. So in a transistor, I will remember the principle of the transistor as well. So you can see if there is a IB current, what's happen? So current from the collector to the emitter will flows, flows. So like that, if the gate signal receive, if the gate signal receives a low power control signal, its control is high power load. That means it allows to the power supply current to reach the load. So by the electrical actuators that we can use it to switching motors, control the heaters, and also driving relays. That means in the all formats of the on-off type control signals can be controlled using the electrical actuators. Okay. The next one is electromechanical actuators. So most common electromechanical actuator is the motor. So you know a motor converts the electrical energy to mechanical motion. So that's we call that it is as the electromechanical actuator. So it receives the electrical energy and convert into mechanical energy by performing a rotation action. So there are many types of motors. So one is DC motors. So it's operate using the DC voltage. And we can use it for speed control, and by varying the voltage that the speed can be controlled in DC motors. So therefore, these motors are used in robotics, in toys, and also in small machines that we can see. The DC motors are used. And the next one. So these are DC motors and AC motor. So normally AC motors operate using the AC voltage, and these are most commonly used in industry. That means the AC motors normally used in large machines because these are very cheaper and robust. Cheaper means less expensive and robust. So normally these AC motors also can we can found as the induction motors, synchronous motors, and as the universal motors. The next one is the stepper motors. So we can see a stepper motor. So normally this moves one step at a time. So that means it moves step by step, and therefore it has high positioning accuracy. So therefore it's widely used in industrial control applications which should have a high accuracy. So therefore in CNC machines, printers, in robotics industry, that we use these stepper motors. And the last one is the servo motors. So the servo motors provides a precise angular control. So normally not like the AC or DC sensors or the stepper motors, they have a feedback controller. So that means it gets the feedback of the angle it is positioned. And also in the servo motors, that there is a gear system also. So therefore, to have the precise angles that we use servo motors. So normally we use these servo motors in it is also used in robotics and in automation systems, uh, in camera positioning, that we can see the servo motors. The third type is the electromagnetic actuators. So normally electromagnetic actuators work using magnetic fields. So the most common example is the solenoid. That in the last lecture that I have mentioned what is an inductor. So like that, an inductor that we can say say it as a solenoid. So we can see a solenoid is used in the electromagnetic actuators. So what's happened? When the coil is energized, when you are energizing a coil, a magnetic field is generated. So therefore, according to that magnetic field, generated magnetic field, the iron core moves linearly. So we can see that this iron core can move according to the magnetic field of this solenoid. So it can move up into the right side or left side. So what's happened? You can see according to the position of this iron core, this bar, you can control the airflow. So therefore, you can control the flow of current or even a pneumatic called liquid flow. So you can see normally in this case that we are using the electromagnetic actuators. So therefore, this movement is used to change the direction of the supply. So we can say these solenoids can operate as a directional control valves. So this creates a push or pull action. You can understand here by this solenoid, it creates a push or pull action. Um, so this is used in the automation industry and in the fluid control and in locking mechanisms that we can see the using of the electromagnetic actuators. So the advantages of the solenoids are normally as they are working with the electric field and the magnetic field, those are very fast and simple. So therefore, you can have fast, accurate, and simple actions or movement. So as well as this is moving, it is very suitable for short strokes. Okay. Then the fourth one, that's the last part of that the actuator that we are going to discuss. It is hydraulic and pneumatic actuators. So normally these actuators are used where to give large force or motion. It can be rotary or linear motion. So when you are required a large force or a motion in high range, these type of actuators are used. So we can consider that means we can divide these pneumatic and hydraulic actuators into the pneumatic actuators and hydraulic actuators. So normally the pneumatic actuators use compressed air as the working fluid. And normally these pneumatic actuators are also gives a fast response. And not like the hydraulic actuators, these are very suitable for giving a low to medium force. So using these qualities that we can use these pneumatic actuators in in the packaging machines, that's meaning automation lines. Uh, and we can find pneumatic cylinders and air motors, and those are the example and the applications of these pneumatic actuators. Mm, and the next one is the hydraulic actuators. Uh, in the pneumatic actuators that you could see that they are used that of the compressed air. In the hydraulic actuators, and normally they use the hydraulic oil as the working fluids because not like air, the hydraulic oil is incompressible, so it cannot be compressed. So as it is not compressed, that we can use it to work with large force, high forces, but not like the pneumatic actuators. Pneumatic actuators are quick reaction. That means it gives fast response. But the hydraulic actuators, they are more accurate but very slow. So normally these hydraulic actuators are used in uh, heavy machinery, and the equipment that we can see in the construction fields. You can see these backhoes or like that. So normally they are we can see hydraulic systems because it can maintain high force for long durations, not like pneumatics. Okay. Uh, then let's move to the typical applications of the sensors and actuators. So this table or this diagram shows how the sensors and the actuators are work together. So here you can see some fields. That mean aircraft industry, automobile industry, home heating systems, milling machines, robots, wood drying cleaning. So in these fields, you can see what are the sensors and what are the actuators that we can see by this diagram. So so you can refer this. I do not going to mention these things sensors one by one because actually we already discussed about these things. Uh, and this is uh, some assist for you to remember the using of the sensors and actuators because you can classify those into various uh, industries. And so you can see here by the sensors, it measures the physical parameters and provide the feedback. And here are the actuators. They execute control actions. So normally this interaction normally performs a closed loop control systems. So it's like normally closed loop in the control system with feedbacks, which is given by sensors. So in the modern automation, that we can say it is like a It is like the backbone. Okay. So you can refer uh, this diagram of the sensors and actuators. Uh, so that's okay. And that concludes today's lecture on the actuators. So before we end, please let me know that do you have any question about these parts? Or have you any actuator types that you want to further clarification on it? So please let me know. Uh, if not, I can conclude the lecture now. As I have informed that you will have another lecture from the Niroshan sir as well. Uh, so okay, I will conclude this lecture. So thank you for your attention. Okay, I will end the lecture. So uh, so I have got a question. So logic gate part එකක් තියෙද? ඔව් logic gate part එකක් තියෙනවා. ඊළඟට තියෙන part එක තමයි logic gate part එක. So I will do it in the next lecture. So now you know the your exam will commence on the 13th, and you will have a study leave of 1 week. So therefore, till the 5th of January, I will do the lectures, and on that day, I will conclude complete the syllabus, and on that case that we will have the logic gate part. Okay, this is for today. Okay, and thank you for joining the lecture, and I will end the meeting. So good night all.